All right, guys. Yeah, so this class is going to be about sort of a couple different things. I'd sort of lump it all under problem solving, I guess. But at any rate, it is going to be a code-free class, at least for the biggest chunk of it. So I'd like everyone to close your computers. Now, I know you're wondering, like, oh, but I like to take notes. Don't worry about it. This is mostly just going to be sort of like talking through stuff and just sort of reasoning things out. But if you want to, like, I don't know, like grab out a piece of paper and a pencil or something, that's totally fine. I've got some over here. I'm not saying you'll need it, but just some people, like, need those notes as a security blanket. The first thing I would like you to do is, well, and actually, now that I mentioned that, there's also going to be at least some sort of moving around the room and, like, shuffling up into different groups, so just be forewarned. The first thing I'd like you to do is look at this guy and tell me what's going on here. What is this?
It's a button.
Yep. And what else? No, don't worry about the code. Yeah, it's a button, and it's being pushed, right? Bless you. So how do you know it's a button?
It looks like a button.
Okay, what about it makes it look like a button?
It has the circle things on the side.
Yeah, so it's rounded. Okay, cool. So I'd like you to take 1 minute with the person next to you just to talk about what makes this look like a button. And how do you know when it's pushed? What specifically lets you know that it's been pushed? Because this obviously isn't a real button, right? This is just like some stuff on a screen. So how is it that you know that just this stuff on a screen is a button being pushed? So take 1 minute. If you're not sitting right next to someone, then please scooch over so that there isn't an empty chair between you. And I'll give you 1 minute. All right, get set, go. All right, start wrapping it up. All right, so what did you come up with? How do you know that this is a button being pushed? Yeah, give me one thing.
I was saying, how do you know it's even a button? I mean, you could easily design that and have animations. How do you know it's a button?
Okay, how do you know it's a button?
I mean, you can kind of tweak that. You can have a border radius. You can have animations to do that. So you can design it for saying you don't know if it's really a button unless there's no way to tell it's a button unless I'm coding it. Because I couldn't design that and make it do that.
Yeah, no, you're absolutely right. There's no way of knowing that this is a button, and you know it's not a button. But like when I first asked you guys what's going on, pretty much everyone said it's a button and it's being pushed. So my question is, how did you know that? How did you know that it's a button being pushed? If you think about it for a while, you can get all existential and say like, oh, maybe it's not a button. Maybe we're not really. Maybe it's not really a universe. How do we know? But yeah, Muhammad, what's one thing?
The perspective change.
Can you be more specific?
Yeah, so the top of it darkens a little bit.
Okay, so top darkens.
The word push goes down as the top darkens, making it seem like it's being pushed down.
Okay, so push goes down.
The word push, we just relate it to, if there's like a button, our brain relates the word push.
Okay, so push equals button. Anything else? Yeah.
The fact that it's within something greater, you think the button is even part of something.
Okay, so it's in something greater or bigger. Anything else? Yes.
It's red, so it's designed to get your attention, so you might want to do something about it.
All right, it's red. Yeah, right.
Just like that, what's that term? Like rounded rectangle shape to be rounded buttons.
Yeah, so it's rounded.
I think the mouse is
Oh.
inside of it, so it kind of makes you.
Oh yeah.
I didn't notice that.
Notice it.
That's actually totally a mistake. The mouse shouldn't even be on top of it. But yes, you're absolutely right. Yeah.
I think the range of motion is it's realistic to think that this is a physical object.
All right. So range of.
Because if the push slid all the way to the bottom of the element, it wouldn't look right.
Pretty kind of weird. Yeah. Yeah. So what's cool about this, what you guys have just defined, is the bare minimum necessary for you to recognize something as a button. And presumably, if this is the bare minimum necessary for you to recognize something as a button, it's the bare minimum for pretty much anyone to recognize something as a button. That is, if all of these things are true of some thing, then you'll think, oh, it's a button. So if the top of something darkens, if the text goes down, if it says push, if it's red, if it's rounded, then you'll think, oh, it's a button. So the reason that we're talking about this is, well, for one thing, you've also defined all the code I actually wrote to make this button go up and down. So when it goes from like unpushed to pushed, 4 things happen. It's all in CSS. One is the border top width changes. The border bottom width changes. Yeah, the color's not great on here. The background color actually also changes. It gets a little bit darker. And the padding top changes. That is what makes the text go down. So with just those 4 things, I've created the illusion of a button being pushed. So this isn't really a class about, like optical illusions or like cool visual hacks you can do in your code. But it is a class about the bare minimum you need for an effect to take place. So it's one title I was working with for writing this lesson plan was faking it. Because that's a lot of what you do in programming is fake things happening. So for an example, when you guys were working on your project, a lot of you were doing the memory game, the concentration game. And I saw a lot of you, you wanted the card to flip over, so I saw a lot of people Googling how to make card flip over. And I'm not going to name names, Sarah, but I know that some of you, ended up looking at like, the results you got were like 3D engines and like how to do like crazy 3D effects and stuff. And if you don't need crazy 3D stuff to make a button look like it's going up and down, you definitely don't need crazy 3D stuff to make a card look like it's going up and down. I mean, as I think you all saw, really, for a user to believe that you have a card flipping over, all you need to do is hide the text on it and then show the text on it. And if you're feeling really fancy, maybe you could say you flip the card over. But even that, even that's overkill. All you really need to do is hide and show the text. So a big thing of what we're talking about today is reality, the real world, versus what goes on in code. When you're trying to create stuff in a program, just by human nature, you want to make things seem exactly the same way they do in real life. You want that card to actually flip over. You want that button to actually go in and out. But the more you try to make things look the way they do in real life, the more difficult coding is going to be. So it's the same thing with writing books. Let's take Harry Potter. Everyone loves Harry Potter, and if you don't, I don't care. We're just going to assume that everyone loves Harry Potter. And people love Harry Potter because you can visualize everything in it so much. It's so rich, it's so vivid, and you can really see everything that happens in it. But that's mostly your imagination. J.K. Rowling didn't actually say, she didn't detail every freckle on whoever's face. She didn't write every single thing that happens. She wrote just enough that you can sort of fill in the gaps yourself. She wrote actually a very small amount. There are a lot of gaps. There's a lot that you imagine when you're reading those books. But she wrote it in such a way that imagining that stuff is really easy. And it's the exact same thing with writing code. If you want a card to flip over or a button to go in and out, there's very little that you actually need to put in there in order for the user to think that that's happening. There's very little, and if you try to put all of it in, you're going to be coding forever. If J.K. Rowling tried to make Harry Potter 100% realistic and tell you every single thing that's happening in it, she would still be writing the first book right now. So, With that in mind, the big thing to think about here is that the more you try to make your code look like reality, the more difficult it's going to be. The reality is your computer is just a box with lights in it. I mean, that's really it. And when you realize that, it can actually take a lot of the stress off you to make your code work. So just to go into a couple of examples, let's take a look at Google Maps. So I'm going to pull up the location of General Assembly on Google Maps. What is south of here? So here's GA. What's south of GA? What's one thing? The White House, right. But, you know, obviously that's a trick question. We're looking at something on a computer screen. There is no south. I mean, to ask what's below here, that's nonsensical. There's nothing down there. There's like not even nothing down there. It's like asking what's outside the universe. I mean, all we're seeing right now is just a whole bunch of lights on a page. But they've made it in such a way that you get the feeling that you're looking at a big world map through binoculars, just looking at like a tiny little piece of it. Now, is the entire world map loaded in my browser right now? No, because that would be enormous. That would be gazillions of gigabytes, and it would make my computer overheat and melt. And so that's not happening. But they create that effect. So check out what happens when I go over to the right. You can see that things are pretty blank over here, and then they start getting filled in. And so Google is just loading information as necessary. They're just making stuff show up on the page as necessary. And from that, you know, I'm getting a tiny, tiny fraction of the data they actually have, but I'm still getting the effect as if I had all the data they have. Another example. So you guys might remember these things. These beta brights. You guys know what I'm talking about with like the lights that go across? No? Come on. Yeah, you've totally seen these before. Everyone's seen these before. Yeah, and so like the text goes across the page, right? Is the text actually going across the page? No. What's happening, Andrew?
The lights are just like turning on and off to give off the image that they are.
Yeah, exactly. The lights are just turning on and off. I mean, this computer is just a big glorified beta bright. It's just a bunch of lights turning on and off all the time. Every single pixel on the screen is just 3 little lights. The lights are really big here, they're really small on your computer. Each pixel is 3 lights, one red, green, blue, and they just turn on and off. And that's really all your computer does. Everything that you see on it is just basically faking it. It's just some sort of an illusion that gives you the feeling of something happening without it actually having to happen. So one more thing. So here is Mario from Super Mario 64. So here's another question. What is behind Mario right now? Like what's over here and over here? No, nothing. You know, it's the same thing. There's nothing over here. If the entire universe in here was loaded, then that would be way more memory than your Nintendo 64 could ever hope to hold. What goes on in these 3D games is they just load different perspectives as you need them to create the illusion of you running through a world. But there's nothing over here. I mean, there's like not even nothing. This is just dry erase board over here. There's nothing over to the left and right. So the way I wrote this in my lesson plan is that if a tree falls in a forest in a video game and no one's around to hear it, it really doesn't make a sound. In fact, the tree doesn't really even exist. Like maybe there's some bit somewhere that says there is a tree at this coordinate, but that's it. Maybe it has a variable saying tree is fallen, tree is not fallen. But that's it. If you're not around to perceive something in a video game, it doesn't happen. All of this stuff is just loaded on a need-to-know basis. As you're walking around, all of this stuff is just pulled in as you need it. So we're not going to look at it here, but if you want to read more about how this works in video games, at the end of the lesson plan, and I know you're not looking at the lesson plan, but at the very end, there's this thing, Making of Crash Bandicoot, which is like one of the first real 3D games ever made for some sort of a console. And they were making it on this early version of the PlayStation, which had very, very little memory. And so making a 3D world for something with so little memory was almost impossible. And in order to make it work, they had to really like crunch things together, be super efficient with their code, figuring out exactly how many polygons to load at like every single point in this game. That's one reason why there are so many trees in this game, because it hides a bunch of stuff. So there's less stuff that needs to be on the screen. And so in that way, they sort of preserve memory. That's the entire reason why Crash Bandicoot takes place in a jungle, was because there's more stuff to like hide things. So it's really interesting stuff, and it's not very codey at all. So yeah, we haven't really talked about doing anything yet. I've just sort of been standing up here preaching. But are there any questions so far? Any thoughts or anything? Yeah, Brennan.
Just something you meant. I have a real world example that you reminded me of when you were talking about the more lifelike you try to make something, the more difficult it is to code. Is that, when at my old job, we were working with like a third-party designer who was not a developer, and they sent over like PSDs, like Photoshop files with a lot of complicated gradients and all these sort of. And when our front-end guy got that and was trying, he was like, "Oh my god, this is gonna take me forever." And they use a bunch of images and stuff like that instead of actually just coding it.
Yeah, I mean, look at vertically centering things, which is, CSS has had 20 years to work on that, and it's still really, really hard. I mean, that's one little thing that seems, totally intuitive for anyone who's not a developer. But for a developer, it's like, oh, Jesus, I got to do that. Last thing I want to show, last visual aid for right now, is the obligatory Xkcd. And so yeah, this is pretty much your job, is just making the lights show up in the way that you want. And I mean, that's really it. Like, you can think of it as a more complicated thing, but it's really just making lights show up in a proper way. There's a lot of complicated logic that makes those lights show up in certain ways, lots of shortcuts that have been built into this computer to make lights show up in a certain way. But at the end of the day, the point is to make lights show up in a certain way. And if you want to be fancy, make sound come out. But even that is just, a little membrane vibrating. So with all of this sort of faking it stuff in mind, I want to go to another example that I'd like you guys to talk about. But before I get there, I'm going to split everyone up. So there are 5, 9, 13, 18. So why don't we do 6 groups of 3? So I'd like everyone to please count up to 6. We'll count off by 6s. Ewan, can you start?
1, 2, 3, 4,
5, 6,
1,
2,
3,
4,
5, 6,
1,
2,
3,
4,
5.
6.
Awesome. So please right now go ahead and get with your number.
You guys come to the front?
Sure.
Alright.
No, I'm staying here.
Yes, sir.
That's right.
All right, so when you're with your group, we are going to look at this thing, which is more CSS. So it's that little guy flying around. I would like you to take 5 minutes to answer these 4 questions right here. So just these 4 right here. The most important one is this last one. So as literally and technically as possible, describe what's happening on that page. So not something is flying around, but like what is actually happening on the page. Not what looks like is happening, but what is actually happening. So please take 5 minutes and go ahead and start to work on those. If you want a dry erase marker to write stuff down, I've got lots up here. Yeah, by all means.
Not simple.
Does it?
It's like that.
I guess there is.